Okay, sorry the video stopped. This middle example is formed by a secant, this top line, and a tangent, this bottom line. So the vertex is still outside of the circle. Over here, this vertex is still outside of the circle. This time it's formed, these two are two tangents. So it can look a variety of different ways, but since the vertex is outside the circle, the angle is going to equal 1/2. And now we need to look at it. Well, here's the angle, and then the angle intercepts these two arcs. When it's inside, you added them together, but when it's outside, you're going to do 1/2 the big arc minus the small arc. So this would be the big arc. This is, whoops, not small. And this would be the small arc. This would be the big arc. This would be the small arc, and right here would be the angle. This would be the angle. This is the small arc, and this whole thing around here is the big arc. Now, if you notice in this last example, the big arc and the small arc come together and form a circle, which we know adds to 360. Okay, but we'll see examples like that in a minute. All right, go back to these notes. So each time you have to ask where the vertex is. So on this one, the vertex is on the circle. So when it's on the circle, the angle, which is angle 1 this time, is equal to 1/2 of the intercepted arc. Well, this is the intercepted arc, so it's half of 150, which would just be 75 degrees. All right, over here, example 2, where's the vertex? Outside the circle. So when it's outside the circle, the angle, which is angle 1, equals 1/2. Now we got two intercepted arcs here, but when it's outside, if you look at your other notes, it's going to be big minus small. So 100 minus 60. 100 minus 60 is 40, so it's half of 40, so the measure of angle 1 is 20. Example 3. Here's the vertex. It's inside the circle. So when it's inside the circle, the angle, which is angle 1, equals 1/2. And when it's inside the circle, we end up with two intercepted arcs. Well, that's the case. It's going to be 1/2 the sum of the two arcs. So 72 plus 50. Okay, so if we add those together, 72 plus 50 is 122. So it's going to be half of 122, which is just 61. All right, example 4, the vertex is on the circle. So when it's on the circle, the angle, which is 5x, equals 1/2 of the intercepted arc. Here's the intercepted arc, so it's 1/2 of 190. Which is 95. So we have 5x equals 95. Divide by 5. So x is 19. All right, let's try some more examples. Example 5. Where's the vertex? Well, it's inside the circle. So when it's inside the circle, well, this time the angle is an x. 80 is x, but it's still the angle, which is 80, equals 1/2 the sum of the two arcs. So here's one arc, here's the other arc. So we're going to have to add them together. Now, when it's all numbers, I can take 1/2, but I can't take half of x. So if you remember our trick, we're going to multiply both sides by 2, so the 1/2 and the 2 cancel, which leaves me with 160 equals 120 plus x. So we'll subtract the 120, so I get 40 equals x. Okay? Remember, you got to ask, where's the vertex? And always write your equation so it's the angle equals something. All right, where's the vertex? Right here, outside of the circle. So when it's outside of the circle, the angle is always the variable or the number right next to the vertex, which is x, equals 1/2. And when it's outside, it's the big arc minus the small arc. Well, the big arc is this whole thing over here, which we don't know just yet. We were given the small arc, so we know it's going to be minus 80. Now, we don't know the big arc directly, but we do know that the small arc and the big arc form a circle. And in a circle, all the arcs have to add to 360. So if I take 360 minus 80, that gives me 280. So now we know that the big arc is 280. So now to simplify this, 280 minus 80 is 200. Half of 200 is 100. All right, more examples. First question, where's the vertex? Right here. It's outside the circle. When it's outside the circle, the angle, which is the number variable closest to the vertex, so the angle equals, you're going to write the same thing every time, and when it's outside, it's 1/2 the big arc minus the small arc. So if I'm looking at my two arcs, well, 75 just looks bigger, doesn't it? And the big arc is always going to be the furthest away. So it's going to be 75 minus x. Can't take half of x, so I'm going to have to use my trick where I multiply both sides. Multiply both sides by 2, and on the right, these cancel out, so I'm left with 40 equals 75 minus x. So now I'm going to subtract 75, and that leaves me with negative 35 equals negative x, which is okay because now we know that positive x equals 35. Okay, let's look at example 8. First question, where's the vertex? Here's the vertex. It's inside the circle. And the angle is always the number variable closest to the vertex. So 77 equals. When it's inside, it equals 1/2 the sum of the two intercepted arcs. So if I look, here are the two intercepted arcs. X plus 109. I can't take half of x, so I'm going to multiply both sides by 2, which makes it cancel on this side. So on the left, I have 77 times 2, which is 154. So I get, 154 equals x plus 109. And now to solve, I'll subtract 109 from both sides. 154 minus 109 is 45. So 45 equals x. And we're done. Okay, example 9. This is not labeled really well, but the vertex is right here, and this should be the center. Okay, it's going to be obvious to you in your homework if there's information that lets you know that. So when it's on the center, the angle, which is always closest to the vertex, is 78 equals, well, it's on the center, it equals the arc. Well, here's the arc, so it equals 3x plus 15. So we'll subtract 15. 78 minus 15 is 63. So I get 63 equals 3x. Divide by 3, x is 21. Now this right here with the vertex on the center formed by two radii, that's a central angle. We've had that multiple times before today. Okay, example 10, the vertex is on the circle. It's formed by two chords. This is an inscribed angle. Not all these angles have a name, but some do. But when the vertex is on the circle, the angle, which is closest to the vertex, equals 1/2 of the intercepted arc. Here's the intercepted arc, so it equals half of 106. So 2x equals, it's not a variable, I can take half of it, half of 53. I don't know, this comes out to be a decimal, but that's okay, we're not going to stress out about it. You get 26.5. Okay, just a few more examples. Example 11. The vertex is right here. It's on the circle. So when it's on the circle, the measure of the angle equals 1/2. Now this is not saying that angle is 1 degree. It's saying it's angle 1. Okay, so it equals 1/2 of the intercepted arc. So it's 1/2 of 224. So the measure of the angle equals 112. All right, example 12. The vertex is outside the circle. So when it's outside the circle, the angle, which is the one closest to the vertex, 47, equals 1/2 big arc minus the small arc. So if I look here, here are my two arcs. Well, x just looks bigger and it's further away, so you know it has to be the big arc. So it's going to be x minus 62. If you set it up wrong, it's not going to come out nice. Alright, so I'm going to multiply both sides by 2. And I get 47 times 2 is 94. So we get 94 equals, these canceled, x minus 62. Here I need to add 62 to both sides. 94 plus 62 gives me 156. So I get 156 equals x. Done. Alright, last two. Example 13. The vertex is on the circle. So when it's on the circle, the angle, which is closest to the vertex, x, equals 1/2 of the intercepted arc. Here's the intercepted arc. We weren't given that arc, but we can figure it out because, you know, all the arcs in a circle have to add to 360. So I'm going to do 360 minus 190. Obviously this picture isn't drawn to scale. 360 minus 190 gives us 170. Okay, so this is half of 170. Oops, we don't need to write that out. And half of 170, well, divide that by 2, get 85. Alright, one last example. X is outside the circle. So there's the vertex outside. And when it's outside the circle, the angle, the one closest to the vertex, equals 1/2. When it's outside, it's going to be the big arc minus the small arc. They gave you one of those arcs. They gave you the big arc. That's 240 minus the small arc. This is the small arc right here. You weren't given it, but we can find it, just like we have been in all the other ones. We can take 360, because they form a circle, they got to add to 360, minus 240. That gives us 120. And that is the small arc. So now when I subtract, I have 1/2. 240 minus 120 is 120. And then we get 60 degrees. Alright, now it's your turn. You can try these on your own on your homework.